But remember, during this training, we have several challenges that we have to went through. Okay, I mean we have to go through actually. For example, so let's come back one by one. It's really training a model is not an easy task. Why? The reason is that the data that you have, for example, the house price prediction that you have seen, is it's not like every time the data that you have will be so easy that you will have a linear relationship between the inputs and outputs. It is not possible always, right? So what are the possibilities, situations you have to handle? It's something like the first one that we have is called underfitting. What is underfitting? Trained model is not working well on trained data. I'm sorry, yes, a trained model is not working well on the trained data and cannot generalize new data. What does it mean? It means that, just like forget about machine learning, I'm telling you an example that I'm teaching you something, some particular subject, okay, and somehow because of my lack of teaching capability, the examples that I have shown you is not very good at all, so that you are not able to learn the relation between the inputs and the outputs. So naturally, what you can say, you are not properly trained. With which data? The data with which I'm giving you the training. That is what called training data, train data. So definitely, if you are not able to get trained even with some given examples, naturally that example is not the only set exist in the world, right? There are many other examples possible for the same chapter, right? So you are not able to understand, or you have not properly trained by the trained data. So naturally, for the other data which is not used for training, you will not able to capture that, right? And that is what we call generalize. It means that I'm not able to understand the relation between the data, so that I can make a general model which can give the closest prediction for all the unknown inputs. So this is what we call underfitting. But there is one more thing, what we call overfitting. Overfitting means, what is written here, the trained model is working well on trained data but cannot generalize new data. How it is possible? What is the situation? The situation is something like, I have rigorously taught you with some set of examples, very rigorously, and you only have taught have been taught by those set of data only, no other data. For example, for example, take a particular, say for example, we have a logarithmic chapter. Oh, sorry, some calculus chapter. Okay, I have rigorously trained you by set of some particular calculus problems. And what you have done? Naturally, only for those calculus problems you can easily solve that. But since I have taught you so rigorously, I have not given you the idea of the other calculus problems. So what happened? You were able to solve those calculus problems that I have used to teach very easily, but you cannot solve properly the other calculus problems mostly. That means that you are not able to generalize the calculus problems for all the unknown problems that has not been used for teaching. So it's like that's why it is said that cannot generalize new data. And obviously trained model is working well. So this is two situation that any machine learning engineer face an issue during training a model. What we have to do? Somehow we have to create a model that will be somehow in between this underfitting and overfitting. What we call basically a good fit. Good fit means it's trained well and also it generalizes the data. Now, what does it mean? Trained well. Trained well mean that it is giving accuracy 100% for the training data and also giving accuracy 100% for the new data. No, it's not possible. But what it is doing? It is actually giving a trade-off between this underfitting and overfitting situation so that it can generalize the it can generalize, or you can say it can optimize the result as close possible to the actual data. Okay, so let's see one by one overfitting and underfitting versus the good fit. So let's start with underfitting first. As you can see in the right hand side, there is two image. In the left hand side, it's something like this particular dots is representing that for a particular set of input, what is the output. These dots are actually the training examples, remember. Okay, so what this particular representing? Again, I'm telling you that see, in the x-axis we have input, in the y-axis we have output. That means for input value x equal to say for example 0.1, the output is for example 0.9. Assume like this. So if you have this example, you can easily put them in a graph. You can easily plot that, right? So if you just plot as a dot for each and every example, the different dots can be something like this, right? Now, for example, I'm using all these dots as a training data for training a model, and ultimately what we find? We find some particular, some particular function, right? So for example, the input is x and output is y. So this output must be somehow related with x, right? So y is equal to fx. This f definition of this f I don't know, but I have this data. So what I am trying to find out? I am trying to find some representation of the function definition, right? Now this particular f may be a straight line, a equation of a straight line, or maybe a equation of a curve, right? If the f is represented in form of straight line equation, then a straight line can be something like this. But you see, is it really generalizing the data properly? You see, what actually I'm trying to do here? I am trying to generalize a model so that it can represent the pattern that we have in this particular plot. And pattern says the pattern looks something like this, what is given here, right? It's the pattern. Maybe this particular line has not touched each and every point, but what you can say that this particular line actually goes through the points so that for each and every point the distance between the point and the line is closest, is optimized, right? Now naturally, if you have this type of straight line, it cannot generalize this particular pattern. This is a situation of underfitting, you can say. Okay, so you see, what are the reasons we can have for underfitting? One can be very simple model. Very simple model. So what is the solution? Definitely we have to go for some complex model design. Or maybe there is a situation that we have not enough training data. But if it happens, it may happen sometimes, because It's not like only by 10 examples a particular black box can learn the relation between the inputs and outputs. Maybe sometimes you look at thousands of examples and maybe more than that. Okay, which sometimes not present in the dataset. So in that situation, there are two different way actually you can do actually. Either you can go for creating more examples somehow, or maybe you can go for better feature selection. What does it mean? Feature selection. It means that, for example, I'm taking an example again, like assume that I'm trying to differentiate between images of a human being and a, say, dog or cat or something like that. Okay. Now here, human being is an object, dog is also an object. Each and every object has some property. Now I can use this number of eye present in the object as a property, as a feature, right? But you see, the number of eye for human being also 2 and for dog is also 2. If you use this number of eye as a feature, is it going to give any important difference between these two objects? No. So that means the features that you are using to represent the object, all the features may not be useful. Even some features can harm the learning. So in that situation, we have to first identify which features are useful, which features are not. So naturally, number of features will get reduced. That is what we call actually feature selection. How we do this feature selection, that I will come in the later part. But this is also one way so that you can make your training better. For example, training better in the sense, for example, just like as I told you that I want to make a model which can segregate, which can differentiate between a man and a human being and and a dog or cat or something like that. In that case, if you give number of eyes as a feature, that particular feature is simply going to give a wrong direction on the training, right? Because there is no use in the number of eyes. In both cases it is true. So this, if you omit all these um, unusable or unusable features, basically, definitely the training will get the power of the training will get increased. So some, maybe you will get less overfitting, sorry, less underfitting in that case. So now you see, I've written here a note for you that always choose the features which has low correlation. Now, what does it mean? That correlation means how, for example, there is two uh, variables x1 and x2. The correlation between x1 and x2 is that how the x1 and x2 are changing in with each other. There are two different situations. I mean, lot of different situations can arise. For example, x1 is increasing, x2 is also increasing, or maybe x1 is decreasing, x2 is also decreasing, or maybe x1 is increasing, then x2 is opposite, in opposite direction it is increasing, right? But remember, all these three cases, you will see that there is a very high correlation between x1 and x2. Okay. And if you have a very high correlation, it sometimes makes you know it actually hampers the training of a model. So we should go for the features which has low correlation with in between each other. Anyway, we can go in detail later stage of the course. Anyway, so there is one more thing, that is not enough training iteration. What does it mean? It means that, for example, sometimes it happens that you read a particular chapter of a book and you realize that that is not enough for you. What do you do in that case? You go through the chapter again, once again, and maybe once again, I mean more than once. So just assume in that way, like going through a chapter was not enough. That means you had not enough iteration for the training on that particular chapter. What you did, you go it for some more iterations. So you just, you know, going through the chapter again, and this is what we can do. Now this is a story of a underfitting situation. So now what overfitting looks like? A overfitting looks something like this. You see, in the overfitting case, in the left hand side we have a good fit, that already we know. This is a generalized representation. But for a in the right hand side we have a overfitting situation, and you see this particular curve is representing that particular function, right? Because any function, if you put for different value of x, if you put the different value of x in that particular function, you will get some y, right? And if you put those y, you will get some curve. So in the same way, I have got this curve, and you see this curve has touched almost each and every point of the training data. So you will say, oh, this is so good. So for each and every point, I'm getting almost 100% accuracy, right? In the training data, you can see, if you see the accuracy of the model with respect to training data, it will be almost 100%, because for each and every point, it is basically the curve and the point is colliding on each other. So that means that whatever I have predicted on the training data and whatever is actual present in the training data is almost same, right? So naturally, it's almost 100% training accuracy. But is it really representing a generalized model? Because once you will have some new data, say present in this particular part where this red point is red marker is present, in that case you will get a wrong result, because the car will not go in this side, you will get some wrong output, right? So this is what we call overfitting. Now what can be a situation? It can be a situation like it's very complex model. I mean, I have taught more rigorously, as I told you, very rigorously. Okay, so naturally you have to go for some simpler model design in that case, right? And also there is a possibility that training data is not close to the distribution of the data. The distribution of the data in the sense that somehow the data, if you take a statistical view of the whole data set, there has to have some distribution, right? And that distribution, in most of the cases we consider that that should be a normal distribution, right? So that normal distribution maybe doesn't exist for that situation, so that can be reason. In that case, we have to go for some more generalized example, or again maybe we can go for better feature selection. So which one is better, that you cannot say. For a particular problem you have to go for generalized example, for some particular problem you have to go for better feature selection. You cannot say something like this. It's totally based on some experiment. Always remember, designing a good model, designing a best model in the sense, you can say, is always a part of different using different strategy and experiment on the data set. Okay, you cannot say that this is the type of data, for this type of data we have to go for this particular model training algorithm, and this will give the best always. You cannot generalize the model, training technique based on some particular type of data. It's always a part of experiment. Now again we can have that or not enough training iteration, so we can go for again more training iteration and optimize that, right? So this is what basically we have seen, that what underfitting and overfitting is based on some data. So if I take a small example, not example actually, just a overview of exactly what we have learned. It's something like, look something like this. That in the left hand, in the big, I mean, at the middle we have the best model, that you can say good fit, as I said, which is not touching all the points definitely. But if you if you take a average between the distance of the line and the point for each and every point, you will see it's basically lowest average. Okay. Similarly, in case of underfitting, it's basically, it's totally, anyhow it is not representing the pattern of the point. And in case of in case of overfitting, it is representing in so nice way that it's not able to generalize the pattern of the grid actually. So this is all about the basic understanding of a model, what we have learned. Then we have learned how our training data looks like and what are the challenges we can see. Now we will see that what are the different type of learning is there possible in our machine learning algorithms.